Sulfuric acid. Use of sulfuric acid. We can use it to make fertilizer. Superphosphate. Superphosphate are the most widely used fertilizer in Australia. What is superphosphate? This is come from the rock. The bottom picture shows the rock, the phosphate rock. This phosphate rock is high in nutrition. It contains calcium and phosphate. Very good for the plant need. But it have a problem. Calcium, phosphate are insoluble, so plant cannot absorb. But if you boil it with concentrated sulfuric acid, so you boil the rock with concentrated sulfuric acid, now you end up with a soluble calcium hydrogen phosphate and calcium sulfate. They both soluble, and this is superphosphate. And so the plant can have the fertilizer which it can absorb calcium, phosphate, and calcium sulfate. Sulfuric acid also can use to make detergent. Look onto a detergent. The head, the polar head, sulfate. That is come from sulfuric acid. So it's the crude oil with sulfuric acid. It forms into the detergent. Our day-to-day use, our car battery. Inside the car battery, the electrolyte are sulfuric acid. Sulfuric acid also used it as a catalyst very often, as we learned earlier. Sulfuric acid, it is a very corrosive acid. You can use it to clean iron. So you see some rusted iron, if you dip it in sulfuric acid, the rusted layer will dissolve. And it also can use to clean all the grease and dirt because they are very corrosive. Extraction of sulfuric acid. The process called fresh process. Sulfur are plentiful underground. To extract it, you need to have 3 pipes. 2 pipes go in, 1 pipe come out, as follows. First, you pump in the superheat steam. You pump in the superheat steam onto the sulfur deposit, as follows. Once you pump that in, sulfur have a low melting point. 119 degrees, they melt. So, they will melt the sulfur. Now, step 2. You compress air into the deposit. And you force the air in as follows. Once you force the air in, now the melted sulfur will be squeezed out onto the surface. And this is the molten sulfur that you will receive. Student, remember, this is a physical process. Sulfur from solid state become liquid state. That is a physical process. No chemical reaction involved. Contact process. Contact process is the sulfur end up to be forming sulfuric acid. You need to have 3 steps and through 3 different chambers. The first chamber, the burner. Second chamber, converter. Third chamber, absorption tower. We're going to go through one by one. Step number 1. Sulfur add with oxygen forms sulfur dioxide. What is this reaction? Combustion reaction. What's combustion reaction? Any fuel with oxygen form oxide. Character, release heat, always exothermic. So, this burner, you put sulfur with oxygen. Once it starts burning, it will self-sustain and it will produce a lot of heat and forming thick sulfur dioxide smoke. And this sulfur dioxide gas will pump onto the second chamber. When you go to the second chamber, look onto the step 2 reaction. Sulfur dioxide add oxygen forms sulfur trioxide. Exothermic too. Now, the experiment, sulfur dioxide mixed with oxygen go onto the converter with catalyst. Then, out into the coolant. Back into the converter. Out into the coolant. Back into the converter. And form sulfur trioxide. Students will start to ask, what's going on with in, out, in, out? This is a reversible reaction. Pay attention. This is a reversible reaction. So, you want to have the maximum yield of sulfur trioxide, the product. Let Chatelet principle apply. It favors low temperature. Why? Exothermic. It will require high pressure to favor the small number of particles. Now look onto the first temperature. Because exothermic, I put the heat after the arrow. If you can, once they form, you have to lower the heat to give you more product. That's why once they form, you have to keep pulling into the coolant to cool it down because they produce too much heat. And once they form, you have to cool it down again so to make a maximum production. Pressure. You always have to retain high pressure so that you can have the maximum product. Step 3. Absorption tower. You have two equations. Let's look onto the picture first. Sulfur trioxide, you go onto this absorption tower. Number 1, you add sulfuric acid onto this sulfur trioxide. Number 2, you add water. Then it will form 2 sulfuric acid. Why you will have this step? Now let's look onto the equation first. The equation, this sulfur trioxide, you have to add sulfuric acid. Add sulfuric acid to form into oleum. Then this oleum, you add water to form 2 sulfuric acid. And why we have this step? Reason, look onto the state. This is a sulfur trioxide gas. This is a thick, smoky sulfur trioxide gas. And if you put concentrate sulfuric acid liquid, you will change it into liquid state oleum. And this oleum liquid Then you add water, it forms into a liquid sulfuric acid. Remember, this gas takes a lot of space, but once you put onto sulfuric acid, now it becomes liquid. So big volume of gas, you become condensed into a small volume of liquid oleum. And this liquid oleum, you then add water, you form into two concentrated sulfuric acid in liquid state. And this is a lot easier to handle. Now look onto the molecular. Sulfur trioxide adds sulfuric acid. This form oleum. They become liquid. This oleum liquid, student may say, how can I remember this formula? Sulfur trioxide plus sulfuric acid. That is the formula. Now, this oleum, they are liquid now. You add water, it will split into two sulfuric acid. What if you don't do it this step? If you direct put sulfuric acid to water, you can form sulfuric acid, but this is going to form sulfuric acid gas. You will have hot concentrate sulfuric acid gas, and that is very hard to handle. When you're diluting sulfuric acid, that is the rule. You must put small amount of acid into big amount of water. So you have to put the acid onto water, not the other way around. You cannot put water into acid to dilute, because if you do the opposite way, it will release a lot of heat. It will boil violently and splash everywhere. And remember, they are highly corrosive and dangerous. And when you're transporting sulfuric acid, concentrate sulfuric acid, you can put it onto a steel container. Dilute sulfuric acid, you put in the glass container will be okay. Student will soon ask, wait a minute, sulfuric acid, steel container? Steel container means iron container. Acid, does metal react with acid? Does metal iron react with acid? So it will melt the container. You're not wrong. But think about it this way. What is the meaning of acid? Acid is an ionized H+. Ionized H+. Any acid molecule react because of this ionized H+. This H+ ion go attack anything with electron. But when you're on a concentrate sulfuric acid state, they are in a molecular state. These concentrate sulfuric acid are in a molecular state. They are not ionized like dilute acid. So if they are in a molecular state, they don't have the H+ ion acid reaction. So in a pure concentrate sulfuric acid, it have no reaction. You can safely carry under the iron with the iron tank. But once you add water to it, they will become ionized. So in any dilute sulfuric acid, they are H plus ion being ionized. H plus ion will have the acid character. They will attack. So you cannot use iron to contain it anymore. You can't use iron 10 to contain. You have to use glass container to contain. Now let's talk sulfuric acid reaction. Of this page, students may be well familiar. Reaction of metal, acid react with metal oxide and metal hydroxide. What do they form? Acid react with metal form hydrogen gas, salt and hydrogen gas. Sulfuric acid react with metal oxide form salt and water, or metal hydroxide form salt and water. This is nothing new. How about carbonate? Acid with carbonate form salt, carbon dioxide and water, form salt, carbon dioxide and water. This is nothing new. You already know. Now we learn something that is additional. Sulfuric acid, when you're in a high concentrate form, they are a dehydration agent. As on our example, dehydration of ethanol. Dehydration of ethanol that we learned on early topic. Ethanol, when you under concentrate sulfuric acid, it will turn back into ethene and water remove. And that's dehydration reaction. Another spectacular experiment. If you put sugar, you add sulfuric acid in it, you will start to smoke, and soon you're going to be blow up into a chimney of carbon. And this is also a water remove. As any sugar molecule, you have this glucose ring. What's the glucose ring made of? The glucose ring made of the OH, water, OH. So when this OH under sulfuric acid, all the OH will be removed and left with a carbon backbone as graphite structure. Graphite, carbon. So the water removed from the molecule. Sulfuric acid also works as an oxidizing agent. It is a strong oxidizing agent react with metal that I'm going to explain. And for example, copper. Copper is an unreactive metal. It normally does not react with dilute hydrochloric acid or dilute sulfuric acid. But copper will react with concentrate sulfuric acid under the following equation. And what's so special? If you look onto the reaction chart, metal react with acid, you find that copper is on the least reactive group. So the least reactive group normally have no reaction to acid. So acid do not react with copper or silver or gold. So why would it react? Secondly, if there is a reaction, acid react with metal, form salt and hydrogen gas. Acid react with metal hydroxide, form salt and water. Look at this equation. It forms salt and water. And what is this? So, in both criteria, they are, we're talking about acid reaction. You cannot call this equation is an acid reaction because first, acid do not react with copper. Second, if they react, it does not form, it will always form into salt and water or salt and hydrogen gas. It should not form into this product. But if you examine the oxidation state to see the change, if you care about work out each oxidation state, and you will identify copper being oxidized by sulfuric acid. Sulfuric acid reduced. And you see, sulfuric acid from +6 become +4. So that's why they are reducing. That's why we call it reducing, means this is an oxidizing agent. Student, please understand.